Welcome everyone. Today let's continue with the lesson periodic classification of elements, and this is part 2 video of this lesson for class 10 science 1. Alright. So student, in this today's part we shall study about Newland's law of octaves. Alright, so let's study. Okay, in our previous video we did Dobereiner's triads, and what is this? This is also a theory about classification of element, and Dobereiner made groups of 3 elements each having similar chemical properties and called them triads, and he also arranged the 3 elements in a triad in an increasing order of atomic masses and showed that the atomic mass of middle element was approximately equal to the mean of the atomic masses of the other 2 elements. So this was Dobereiner's triads theory about classification of elements. Okay, now let's study a new theory related to the classification of elements. Alright, so this is Newland's law of octaves. So this theory was put forward by scientist John Newland, and the English scientist John Newlands correlated the atomic masses of element to their properties in a different way. Alright, and in the year 1866 Newlands arranged the elements known at that time in an increasing order of their atomic masses. So in the year 1866 there were about 56 elements were known, and Newlands arranged these 56 elements in an increasing order of their atomic masses. Okay, atomic masses including number of a proton and addition of protons and neutrons which are there in a which are present in a nucleus. Alright, and it started with the lightest element hydrogen and ended up with thorium. So element hydrogen having least atomic mass, that is 1.08, and thorium, this is the heaviest element and having atomic mass is equal to 232.06. okay, so it started with hydrogen and ended up the thorium. And he found that every 8th element had properties similar to those of the first element. That is, every 8 element had the similar chemical and physical property of that first element. Alright. For example, sodium is the 8th element from lithium, and both have similar properties. That means sodium is the 8th element from lithium, and sodium has a similar chemical and physical properties as that of lithium. Alright. And also magnesium shows similarity to beryllium, and chlorine shows similarity with fluorine. That means magnesium has 8th element from the beryllium, and chlorine is also 8th element from the fluorine. So this shows the similarity in the property. That means they belongs to the same period. Alright, now next this is a Newland's law of this is a Newland's periodic table. You can observe the first element is hydrogen, and the second last element is a thorium having atomic number as 90 and atomic mass number as 232. Alright, and Newlands compared the similarity with the octaves in a music like all the 8 notes of a music. Okay, so he compared the similarity, that is every first 8th element is having similar property to that first element. Okay, so he compared the similarity with the octaves in music, and he called the similarity observed in the 8th and the first element as the law of octave. That is why this law of Newland's law known as law of octaves. Okay, now next is the limitation of Newland's law of octaves. Okay, so many limitations were found in Newland's octaves law, and this law was found to be applicable only up to calcium. Okay, so these are in the first this is a Newland's law of octaves, and in the first column you can observe the musical notes like sa, re, ga, ma. These are the western and Indian, and do, re, mi, these are the western musical note, and sa, re, ga, this is the Indian musical note. Okay, and below you can observe the different element which were known at the time of a Newland's. Okay, so that this law have some limitations, and this law was only found to be applicable only up to calcium. Okay, and before the only till calcium this law is applicable, and after calcium this law is not applicable. So there are many limitations. So Newlands fitted all the known elements in a table of 7 by 8, that is 56 boxes. That means 7 period and 8 groups like this. and Newlands placed two elements each in some boxes to accommodate all the known elements in the table. That for example, cobalt. Alright, so now just now I have told you that Newland placed two elements each in some boxes to accommodate all the known elements in the table. Like you can observe here, the cobalt and nickel are placed in one same place, and cerium and lanthanum is also placed in one place. Okay. So Newland placed some elements with different properties under the same node in the octave, and cobalt and nickel in one column, and cerium and lanthanum in one column. Okay. So for example, Newland placed the metals cobalt and nickel under the node Do along with the halogens. So cobalt and nickels are placed with the halogens. This is one of the limitation. While ferrous, that is Fe, having similarity with cobalt and nickel, it placed away from them along with the non-metals, that is oxygen and sulfur, under the node T. So this is the main two limitations of the Newland's law of octaves. Alright. And student, also Newland's octave did not have provision to accommodate the newly discovered elements. That means in Newland's periodic table was completely filled. It doesn't have any provision, or it doesn't have any empty spaces for the newly discovered elements. So these are the major limitations of Newland's law of octave, and the properties of the new element discovered later on did not fit in the Newland's law of octave. So these all are the limitations of Newland's law of octave. So student, that's it for today's video. I hope you all have understood this Newland's law of octaves. Thank you.